In this video, we once again will create old school programs for the Apple II, but this time with a modern twist. Instead of writing every single line of code, we are going to use large language models to do the heavy lifting. You might have heard of something called vibe coding, the idea of working side by side with an AI model to write and evolve computer programs. And that's exactly the approach we are going to explore in this video. Let's go. The environment that we are going to use is the familiar Cyanide Applesoft basic editor provided by Paleotronic, and we need a large language model assistant. In this case, I'm using ChatGPT, but you could use Google Gemini, you could use Anthropic's Claude, you could use many different models. The principle is still the same. So the simplest way that we have to do this is we ask the LLM to write a program in BASIC, and then we paste this into the Paleotronic Applesoft basic editor, and we test the program. So let me ask for an example here. Write an Applesoft basic program that is a Wordle game. Make it simple with 4-letter words and make it run correctly in an Apple II computer. We could have written a different prompt, right? We have to try out these things. I really just made up this particular prompt here. And what I expect is going to happen is I get a basic program to be spit out here on ChatGPT, and we're going to paste it over there. Okay, it's doing something. To be frank, just by looking at it, I already doubt it's going to run, but let's, at least in the first attempt, so let's see what happens. So far so good. It's actually asking me something, so I'll try a 4-letter word. I don't know, mood, probably a horrible example. So we have a syntax error, right? Not a very good sign. So line 170. Let me tell it fails with syntax error in 170. All right, so it has now proposed some improvement. So let's copy. So let's try the new version. We click update and then we run. So let's try mood. Oh, actually I got 2 letters right, but in the wrong spot. So we have M and D in this word. Let's try doom. Okay, that's not good. So we have now bad subscript error in 420. The essence of vibe coding is that you are mostly not doing the programming yourself, but you are telling the LLM what to do. So here, what we should do against this new version fails with bad subscript error in 420. Then let's give it some time. We already see that it takes about 25-30 seconds to come up with an answer. Okay, so it has a newer attempt. So let's update again and try it again. Let's try something different. So I had 2 letters in the right spot. So A and E. Tail, maybe. Nope. Fair. Nope. Date. No, yeah, I already knew there wasn't a T there, so that was a silly attempt. Sail maybe? It was Jade. Okay, so we have a fully functional program for playing Wordle in the Apple II. And this has about 500 lines of code. So that's great, actually. I mean, we got this result super fast, but we still have the problem that we have to copy and paste and then let it know when it has made a mistake. And this was a simple example, but I tried this with a bit more complicated stuff using graphics. And that was actually much harder. So we wish we had a way that you could actually let the LLM play with the emulator itself, so it can try out things and make mistakes and get it right in the process. And actually we can do that using something called MCP, Model Context Protocol, which is a standard that is emerging for you to connect the LLM to other systems, like in this case an Apple emulator. So let's see what happens if we use this approach. Paleotronic has posted in August 2025 that they have updated their Micro M8 emulator, which is an emulator that you can download and run in your computer, to expose itself as an MCP server, and Model Context Protocol server, which means that it becomes available for LLMs that are capable of dealing with MCP servers to interact with the emulator. So in this post, they explain the same story that I have just told you, that you can use this to vibe code. They even suggest some things that you can do in the prompt to the LLM to increase efficiency. And here they explain to you how to configure this MCP server integration. They say they are compatible with Claude, ChatGPT, and other MCP-enabled clients. I will not in this video get in the details of how you set up this environment. They describe it here, but if you would like to try this out and you're having trouble, let me know, because I can record a video specifically about how to set up this environment. I have already done this using Claude Code and the Micro M8 emulator. So let's see this in action. So here we are, and I have Claude Code to the left of my screen and the Micro M8 emulator to the right of my screen. And this is the splash screen of the Micro M8 emulator. And I just started Claude Code, so I will first just check that it understands what it can do with Micro M8. So I show you here what can you do with Micro M8 MCP server. And then let's see what Claude Code makes out of it. I expect that it will say, oh, I can do things like can load and read programs in the screen. You see, it can do a lot of different things in this connection with Micro M8. So, and it knows that it can do these things. So I would tell it, so write a Wordle word game in Applesoft Basic and run it in the Micro M8 emulator so I can play with it. So Claude first makes a plan for what it has to do, and then it's going to ask you for permission for doing things like accessing your computer's files and accessing Micro M8 and all these things, because even though it has this power to interact with different things, it will not just go out and do things without your permission. So it has already understood the emulator, designed the Wordle game, and now he's actually, well, I'm calling it a he, but it's an it, right? So it has created a program which is not formatted in a nice way for us, but it's the simplest way to send to the emulator. And they say, yes, we can write this program. And now it's going to run it for us. in the Micro M8 emulator. So we see that something is already happening here. Okay, but this is not what I expected, right? So I'm gonna tell it the screen is blank. I don't see the game or a prompt. And the interesting thing is that it can actually get the screen itself and understand what is going on. Now it's going to reboot the emulator. So it has now replaced the... Okay, now we see something. So this one is a 5-letter Wordle. I did not say it had to be 4 letters. I could do that. But let's try it out now. So let's try with Apple. Okay, now we have a problem. So we tell it, when I typed Apple, it stopped with syntax error at line 14. I could actually have just asked it to take a screenshot and read it, but I don't mind typing it. Okay, so we have the game running again. All right, so now I see something. Okay, so it took me a long time to get somewhere. It's like a bit of a ridiculous series of words, but yeah, the game is here. You see, this is really powerful. You can get a game of, in this case, 1,000 lines. This is way larger than the other Wordle program. We just wrote ourselves 1,500 lines of basic with just a few prompts. And of course, part of the fun of working with these 8-bit computers is learning to program them and figure out things on your own. And this is also something that these LLMs can help us with. Maybe it's the more interesting thing. So we can say, like, read the program in the basic program in the memory of Micro M8 and explains to me what it does in a few paragraphs. So in this case, we just used Claude to create the program. But we actually can do this with existing programs that we got from other sources, even commercial programs. We can ask it also to try to understand assembly programs and explain them for us. So you see here we get an explanation. Basically, it's saying that, let me list again so we can go through it together. So it says this Applesoft basic program implements a classic Wordle word guessing game. Yes, that's what it does. The program starts by displaying welcome instructions, setting up the game rules where players have 6 attempts. So this is what we see here. This is what it is doing at the beginning. It is printing to you that welcome to Wordle, and now you have 6 tries, and this is how I'm going to show you whether you guessed right or not. Then it says there's an initialization phase, which we can see here, initializing variables. To create multi-dimensional string arrays to store guesses and feedback, loads a word list of 20 computer-typed words themes from data statements. The word is then broken down into individual letters. The data statements are probably in the end. And then it says that the main game loop handles user input. That's what it's doing here. It is taking the input and it is making uppercase and it's comparing and doing all these things that are described here, and then concludes either when the player successfully guesses the word. This is the logic, and probably at the end we get the data segments. Indeed, we get the data segments here that are basically the words, the database of words known by the program to challenge us. I could ask specific questions. I could say something like, what does the G dollar variable contain? And then it tells you that's an array with 2 dimensions. Let's take a look at G again. You see here it is dimensioning G dollar, and it is providing 2 numbers, which are the 2 dimensions, right? It's 6 by 5. And then we have F dollar. G dollar are the guesses, that's why it's called G. And then F dollar, it's called feedback, which I guess it's where it compares your guess with the actual word, which is probably W dollar, and gives you that feedback of the asterisks or the plus or the minus signs. And here it explains, for instance, to you what G dollar contains. It's indeed 6 rows for up to 6 guesses of by 5 columns for each letter position, and then gives you examples so you understand what's in there. And also we could ask things like, in which lines of code does the program store the words to be guessed? So it's going to think, and I suppose it's going to tell us that's around line 900 and the ones that come. Yeah, that's basically what it tells us, and then explains where it is loaded, which line. So you can see that this thing does not only help you write a program or modify an existing program, but can also explain to you how this thing is working, which is great that when we want to make sense of some of these older Applesoft basic games and other programs that we remember so fondly. So I hope you have enjoyed this video, and see you next time.